Question 11 is all about vectors. So you've been given points A and B with position vectors 2, -2, and -3, -1. And you are asked to find vector AB, which is this one here. So in order to work it out, we know that vector AB is going to be vector OB, i.e. the position vector of B, minus the position vector of A, and we've got that information up here. So vector AB is going to be -3, -1, -2, -2, which is going to give us -5, 1. In part 2, we're asked to find the magnitude of that, which should be straightforward. The magnitude of vector AB is just going to be the square root of 5 squared plus 1 squared, which is therefore going to be √26. In part B, we're asked to find the vector AD in terms of D, and we are provided with the position vector in terms of D here. So similarly, we can express AD, vector AD, as a vector OD minus vector OA. Now we've got vector OD in terms of D here, so that's going to be D23 minus vector OA, which is this one here. And if we subtract them, we're going to end up with an algebraic expression, which is going to be D minus 2 and 25. Next, we are told that angle BAD is 90 degrees, and we are asked to show that D is equal to 7. So we've got some vector up here going up some undetermined length at this moment. But the point is, if we know that this angle here, BAD, is a right angle, because it's 90 degrees, we've been told here, we can deduce that the dot product of AB and AD must be equal to 0. So vector AB we worked out earlier, and we said that that was -5, 1. We know that vector AD in terms of D, just up here, is going to be D minus 2 and 25. So the dot product is equal to 0. So again, when we work out dot product, we take the I components, multiply them together, so -5 multiplied by D minus 2, and we add the product of the J components, which is just going to be 1 times 25 here, which is 25. And we know that that's going to be equal to 0, so we've got -5D plus 10 plus 25 equals 0. So therefore 5D is going to equal 35, and D is therefore going to equal 7. In the final part 2, we are asked to write down the position vector of the point D, and the reason that's fairly straightforward is that we have been told the position vector in terms of D up here, so we know it's D in 23, and we have just solved the value of D as being equal to 7, so therefore the position vector is going to be 7, 23. For part D, you're asked to find the position vector of the point C. Now, because we've been told that ABCD is a rectangle, we should be able to recognise that in the first part of the question, we were actually asked to find out vector AB, and we found out that vector AB was -5, 1. Now, given that it's a rectangle, that also means that vector DC is also going to be -5, 1. And we can also express DC, vector DC, as vector OC minus vector OD. So we're being asked to find the position vector of point C, which is OC, so we can rearrange this equation and show that the position vector of C will be vector dc, which we've just shown is -5, 1, plus vector OD, which we found from the previous question was 7, 23. So vector AC will therefore be 2, 24. Now there are a number of different ways that you could also end up with the same conclusion, but bearing in mind you've already been given vector AB, or you've already figured out vector AB, I think that's probably the simplest. For the final part of question 11, you are asked to find the area of rectangle ABCD. So you have already got from earlier on in the question the magnitude of vector AB, which is √26. So all we need to do then is find the magnitude of vector AD and multiply them together. So vector AD is going to be the position vector of D minus the position vector of A. So that's going to be 7, 23 minus the position vector of A, which is going to give us therefore 5 and 25. So the magnitude of vector AD is going to give us √25 plus 25 squared, which is going to be √650. So the area therefore is going to be √26 multiplied by √650, which is going to give an answer of 130.